Okay, this is going to be the review for the trig unit for pre-calc. This is also will be for unit 6, the pre-calc unit. There's some things before we start this that I'd like to go over. Things that you should memorize, be able to write down when your test starts or your exams start. Okay, first thing is SOHCAHTOA. Understand sine and cosecant linked to this one, cosine and secant linked to that one, tangent, cotangent linked to SOHCAHTOA. The next thing you're going to need is this concept of the triangle. So this is a 30 degrees, pi over 6, which would be the hypotenuse would be 2, the opposite would be 1, and the adjacent would be square root of 3. Okay? For the 45 degrees, or the pi over 4 triangle, you have 2 for the hypotenuse, square root of 2 for the opposite, and square root of 2 for the adjacent. So that's right there. 60 degrees would be 2 for the hypotenuse, square root of 3 for the opposite, 1 for the adjacent, and 60 degrees is pi over 3. So we got to understand that. Second thing we got to be able to do is draw out our unit circle. So 0, 3, 60, or 2 pi. Okay. This is 90, or pi over 2. This is 180, or pi. This is 270, 3 pi over 2. If you use negative degrees, this would also be considered negative 90. This would be considered negative 180. And this would be considered negative 270. So you got to understand all those amounts. Okay. Then we got here, we got this being 1, 0. We have this being 0, 1. We got this being negative 1, 0. And we have this part being 0, negative 1. In quad 1, we understand that all are positive. In quad 2, we understand that just sine and cosecant are going to be positive. In quad 3, we understand that tangent and cotangent will be positive. And in quad 4, we understand that cosecant and secant are going to be positive. Okay? So these are the vital things, all right, that are needed, okay, in order to do the rest of what I'm going to do. So you got to be able to write that out, and we're going to reference that as we go. Okay? All right? Also, I might write out some of the tangent, or some of these measurements. Pi over 4, pi over 3. I know that these will all be from these will be 5 pi over 6. I know this is 3 pi over 4. And I know this is 2 pi over 3. Okay, this will be 4 pi over 3. I know it will be, the 4 one will be 5 pi over 4. And I know 7 pi over 6. This one, 11 pi over 6. 7 pi over 4. And 5 pi over 3. Okay, one of the big things with the radian measures, these are easy because they're just the fractions underneath. You notice that these are all 1 away, 1 away, 1 away, 1 away. These are smaller than 1 pi, because this is 1 pi. This is bigger than 1 pi. So that's how you know which side these go in. Okay, these obviously have a difference of more than 1. Okay, but they are less than 2 pi. So that's vital. Okay. All right. So first thing we're going to do is convert to radians. So I'm going to multiply by 180 over pi. So very simply, I am just taking, for those, I am just taking the radian measure, okay? So I'm just taking the fraction, basically dividing it by 180, okay? Same thing here, and putting a pi next to it, okay? So let's just handle those real quick. 255 over 180. I don't know why that's doing a double. So that's going to be 7/12 pi. Negative 140 divided by 180 is negative 7/9 pi. 75 over 180 is 5/12 pi. Okay, to convert the ones to degrees, pretty simply, I'm multiplying by pi over 180. In essence, the pi's get canceled out. And then all you're doing is basically multiplying the fraction times that. Okay, so that would be negative 2/9 times 180 So in degrees, it's negative 40. Okay, 4/9 times 180 is 80 degrees. And 10/9 times 180 will end up being, just in the interest of time, that's going to be 200 degrees. Okay. Find one positive angle, one coterminal angle. Okay, so when you have the pi's, what I would do is I'd add by 2 pi. And then if you want to find the other side, you subtract by 2 pi. Okay, so what we have to do is make fractions. So times 9 times 9, because I got to get common denominator. So 20 pi over 9 plus 18 pi over 9 will give me 38 pi over 9. If I subtract, obviously that'd be 20 pi over 9 minus 18 pi over 9. Same concept, which would be 2 pi over 9. Okay. For the degrees, it's pretty simple. I'd add 360, which would be 710. And if I subtract 360, okay, I get negative 10 degrees. Okay. All right, on this one, if they wanted to actually get a negative, okay, I'd have to subtract by 2 pi again, which that would be times that would be 2 pi over 9 minus 18 pi over 9, which would be negative 16 pi over 9. Okay. All right, this one, I would add 360, which would give me 240. If I subtract 360, that would give me negative 480. Okay. This one, I'd have to add 2 pi. I would make this by multiplying by 4, so I got 5 pi over 4 plus 8 pi over 4, which would give me 13 pi over 4. Okay. If I wanted to obviously find the other one, I would subtract by 2 pi over 1. So that's going to be 5 pi over 4 minus 8 pi over 4, which would be negative 3 pi over 4. Okay? So basically just make a fraction out of that, multiply by top and bottom. Okay? Let's get on to the rest of the trig stuff. Okay? Find the measure of the indicated side. So what I want to do is this side would be the hypotenuse. Okay? Off of my angle, this side would be the opposite, and this side would be the adjacent. The two sides I have information for are opposite and hypotenuse, which would be sine. So sine is 64. The opposite, the opposite is x. The hypotenuse is 2. The way you solve that is the 2 moves out in front. Okay? So 2 sine of 64 gives me 1.79 for that answer. Okay? This one, I'm labeling off this as the hypotenuse. This is now the opposite. This is the adjacent. So the two letters I have information for, two sides, are opposite adjacent. So I choose tan. Tan of 53 is my opposite amount of 6. This is here. So what I'm going to do is I'm going to switch spots with that. So it'll be 6 divided by the tan of 53. So 4.52. Okay. Moving on to this part. Okay. Find the measure of each indicated angle. So once again, this is the angle I'm going off of. So this is hypotenuse, opposite, and then this is adjacent. So opposite and adjacent is what I have. So tan of theta, in this case, would be 8.8 over 12. And I would do inverse of that. That will actually give me what the angle is. So second tan, 8.8 divided by 12. Okay, that's 36.25 degrees. Okay, going on to this one. This would be my hypotenuse. That's my angle. So if I drew a line, horizontal, a line across, that'd be opposite. This would be the adjacent. Two sides I have information for are adjacent and hypotenuse. So tan of theta is 4 over 10.2. So I would do inverse tangent 4 divided by 10.2. 66.91 degrees. Okay, going on to the next questions. Okay. All right. We want tangent of theta where, all right, is that where cosine is a negative. Okay, so I'm only going to be concerned with, I'm not going to worry about this negative. I'm going to let this help me. Okay. All right. Okay. So what I would have here, okay, is this is opposite over adjacent. Okay. So what I got here is this would be 7. This would be 24. Okay. If I do put PYT, to find the hypotenuse, okay? All right. We'll find the exact values of the 5 trig functions, okay? Not given. Okay, so what I want to do is do PYT, so that's 7 squared plus 24 squared equals h squared. Now, I unlikely know that's going to be 25, but if you followed that out, okay, all right, 24 squared is 576. That ends up being 625. You take the square root of that, that's going to be, h is going to be 25. Okay, so there's the triples with that. Now, what I know is cosine will be negative in these 2 spots, and I also need where tangent would be negative. Well, I know tan will actually be positive here, so it's going to be in this quadrant. So I'm going to work off of the quad 2 concept. Okay, so in the quad 2 concept, the only things that are positive are sine and cosecant. Okay, so what I'm going to do is I'm going to find the rest of these. Sine, cosine, tangent already did, cosecant, secant, and cotangent. Okay, so sine would be 7 over 25, cosecant would be 25 over 7, cosine would be 24 over 25, secant would be 25 over 24, cotangent would be 24 over 7. So the only thing that, since I'm up here, the only thing that's going to remain positive are these 2. Everything else would become negative. Okay? All right, this one. What I would do is I'd put a 1 to help me here. So cosecant is hypotenuse over opposite. So that's square root of 5. And that would be 1, because that's what my opposite would be. This would be the adjacent, and this would be the hypotenuse. Okay? If I follow PYT on this, okay, my adjacent side squared plus 1 squared should equal the square root of 5 squared. That would be 5, that would be 1. Okay, so I'd subtract 1 to there, so the adjacent side squared is equal to 4. If I took the square root of that, the adjacent side has to be 2. Okay, so that's the key thing with that first. Now, what we want to figure out is where cosine, once again, is negative, which will be those 2 quadrants. Now, where this would be where sine would be, happen to be positive. So what I would end up saying is I'm still back in that quadrant, because both sine is positive and cosine is negative. Okay, so that's the quadrant that it would be in. Okay, so sine, cosine, tan, cosecant, get this out of here, secant, cotangent. Okay, all right, so sine would be O over h, or 1 over the square root of 5. Okay, now if I go to rationalize that, I multiply by that top and bottom, so that's square root of 5 over 5. Okay, I already found this one. Okay, so I don't need to worry about that. Cosine would be 2 over the square root of 5, making secant 5 over square root of 2. I'm sorry, square root of 5 over 2. Okay, and then tangent would be 1 over 2, and cotangent would be 2 over 1. These are fine. I still have to rationalize this one. Okay, so 2 over the square root of 5. Square root of 5 times square root of 5, so that's 2 square root of 5 all over 5. So 2 square root of 5 all over 5. Now, since I'm up there, the only things that are going to stay positive are these things. Everything else would become negative. Okay? Use these to find all 6 trig functions. Okay, once again, this is x, this is y. Okay, so this would be adjacent, which we're also treating as x is 4. This would be y, which is also the opposite, which would be 3. If I do Pythagorean theorem, this is going to end up being 5. Okay, all right. Now, I'm going to keep this negative there. And when I do Pythagorean theorem, I don't worry about the negatives. So now I'm going to find all the trig functions. Okay, so sine is negative 3 over 5, which makes this negative 5 over 3. Cosine is 4 over 5, which makes this 5 over 4. And then tangent would be negative 3 over 4, which makes this 4 over negative 3. Okay, going on to this one. Okay, let me erase this part right here so we're not confused. Okay, so this would be my x, this would be my y. Okay, so adjacent x would be 2, opposite y would be square root of 5. This would be my hypotenuse. I might actually have to do PYT here. All right, 2 squared plus square root of 5 squared equals my height squared. That would be 4 plus 5. All right, 4 plus 5 would be 9. Hypotenuse, square root of 9 would be 3. Okay, everything's positive, so I don't need to worry about all that stuff. Sine, cosecant, so sine would be square root of 5 over 3. This would be 3 over the square root of 5. We'll get into rationalize that in a second. Cosine would be 2 over 3, making it secant 3 over 2. Tangent would be square root of 5 over 2, and cotangent would be 2 over the square root of 5. The only ones you have to rationalize are these two, okay? So multiply by square root of 5, top and bottom. That would be 3 square root of 5 over 5. This one, multiply by square root of 5 over top and bottom. That's 2 square root of 5 over 5. All right? All right, now we're going into the trig function stuff, okay? All right, this is going to go to the 45-degree one, all right, which is square root of 2, square root of 2, all right, 2. All right, cosecant is h over o, okay, which would end up rationalizing when you get that to square root of 2. Now, this quadrant will end up being down here, where I know that the only thing is cosine and secant, so that's got to be negative. All right, this is still simply the same triangle as that, so that the opposite over this would be 1. This will obviously be in this quadrant, quadrant 1, making everything positive. Make sure you can see that okay. Yep, so that would be in quadrant 1. 120 would be right here. I would need to figure out the reference angle, which would be to 180, so I would put me in the 60-degree deal. Okay, if you look at the 60-degree, it looks something like this. Okay. We're doing cotangent, which is 1 over the square root of 3. That when I rationalize that, that's square root of 3 over 3. When I rationalize this one too, just to let you see it, okay, I multiply by that, that's 2 square root of 2 over square root of 4. That's 2 square root of 2 over 2, which that cancels. So I like to save myself some time with that. Now in this quadrant, the only thing is going to be sine and cosecant. It's going to be positive, so this has to be a negative result there. All right, 405 is too big, so I'd have to subtract 360. Which puts me at 45, quadrant 1, okay? It's the same 45-degree triangle up here, so that's going to be A over H, H over A, which is 2 over the square root of 2, which we already know rationalizes to that. I'm in this quadrant, so everything will be positive, okay? All right, 5 over 3, that will be in this quadrant, and that will be the 60-degree triangle, okay? Because we know that ties to pi over 3. Okay, so that's square root of 3, 1 and 2. We're doing a over h, okay, which is 1 over 2. Since I'm down here, the only thing that's going to be positive are cosine and secant, so I'm going to leave that as 1/2. All right, 330, I'm still in that same quadrant. All right, I'm going to compare to 360 degrees, which puts me at the 30-degree triangle. So that's going to be 1 square root of 3 and 2, h, o, and a. I am doing h over o in this case, which will be 2 over 1, which will be 2. In this quadrant, we already said cosine and secant are the only things, so that's got to be -2. Okay? 4 pi over 3. I know that that is going to be in this sorry, that's not that quadrant. It's going to be in this quadrant, okay, because that's a difference of 1, slightly bigger than 1, 4/3. Remember, this is 1 pi here. This is 1 pi. 4/3 is slightly bigger than 1, so that's why that is there. Okay, so the only thing there is tangent, cotangent, right, which is what we have, so it's going to be positive. This is going to trace back to the 60-degree triangle, so square root of 3, 1 and 2. Okay, tangent is square root of 3, all right, over 1, which is just going to be square root of 3, and since that is in that quadrant, it will be positive. Okay, this one I have to add 360, which would bring me to 135 degrees, okay, which that one will put me into this quadrant. Once again, the only thing positive there is sine and cosecant, so that result's going to end up being positive. The 135 will trace back to the 45 degrees, which will be this, okay, so I'm doing sine, which is square root of 2 over 2, because that's opposite and hypotenuse, okay, all right, square root of 2 over 2. Okay, I think that's it for that page. Okay. All right, find the values of the 6 trig functions. So once again, I want to do something similar here. I want to do SOHCAHTOA, just in the interest of time. Okay, that would end up being 3. Okay, from doing Pythagorean theorem. So sine Now what I want to do is label. So this is going to be the hypotenuse. I label. This is the opposite. This is the adjacent. Be careful when your reference angle's up in the corner there like that. It changes. So 3 over 5, cosecant 5 over 3. Cosine would be 4 over 5, making secant 5 over 4. And then tangent would be 3 over 4, and cotangent would be 4 over 3. All those are reduced. Okay, here's my hypotenuse, my opposite, and my adjacent. So I would do 2 squared plus 3 squared equals my height squared. So 4 plus 9, it's going to be 13, square root of that. So this is square root of 13. So I got sine will be 2 over the square root of 13, making cosecant square root of 13 over 2. Cosine would be 3 over square root of 13, and making secant square root of 13 over 3. And then tangent would be 2 over 3. Cotangent would be 3 over 2. Now, the only ones that aren't good here are these two right here. So I would have to multiply by square root of 13, multiply by square root of 13. Okay? All right, so what that turns into is 2 square root of 13 over 13. This will be 3 square root of 13 over 13. Okay? All right? So now we're moving on to the inverse trig functions. Okay? All right? One of the big things with the inverse trig functions, all right, is for cosine. Okay? For cosine, this is something you should memorize. That it will be, the domain is restricted for inverse cosine between 0 and pi. Okay? For sine, okay, all right, it is going to be restricted, all right, between negative pi over 2 and pi over 2. Okay? And then for tangent, the restrictions are between negative pi over 2 and pi over 2. We went over this in class of why it needs to pass the horizontal line test. Okay? So you have to be able to do this part without a calculator. Okay? All right, you have to be able to do that part without a calculator. All right, so the idea would be is the only way this can be answered is between 0 and pi. So basically, here's 0, here's pi. The only two quadrants that can be in are right there. Okay, so it means it's got to be in this quadrant. Okay, all right. So what you have to look at is what triangle, if you looked at your triangles, would give you that result, where there's a 2 here and a 1 there. Well, if you look at your triangles, the only thing that would work there is the pi over 3 triangle or the 60-degree triangle. Okay, so all right, we know that it has to be over here because cosine is negative. All right, so this one would be 2 pi over 3 would be the answer for that. Okay, the reason being is this one, 2 pi over 3, would trace back to this exact same triangle, and the cosine would be negative there. All right, tangent. All right, so what I can only look at as far as answers, I can only look at these. Okay, so this is pi over 2, and if I went this way, this would be negative pi over 2. All right, so you look at what triangle would give you that result. Okay, well, pi over 4, okay, when I would figure out the tangent of that, okay, all right, the tangent of that, square root of 2 over 2 would be 1. Okay, so this is the result. Now, since it's positive, the only place it can be positive is there, so that's why that result is pi over 4. Okay, sine negative 1 over 2. So once again, sine is opposite over hypotenuse. So 2, 1. All right, the only triangle that would produce that is the square root of 6 triangle. Okay, so when I look at sine, once again, sine is also going to be these two. Well, since it's going to be negative, it's going to be in that quadrant, which makes that pretty simple. That's going to be just negative pi over 6. Okay, got to be down there. All right, this one, square root of 2 over 2. All right, that would be pretty easy. That's got to be the 45-degree triangle. Okay, all right, it's going to be the 45 or the pi over 4 triangle. And we know with cosine, it's got to be one of these two. Well, the only place that's going to be positive is there, so it's going to be pi over 4. Okay, this one, square root of 3 over 2. Sine is opposite over hypotenuse, so square root of 3 over 2. If you look at your triangles, the only one that would produce with that would be the pi over 3 triangle. Okay, once again, the only thing we're restricted domain-wise, it can either be there or there. All right, well, since sine is positive, this is the only place where it's positive, it's simply going to be pi over 3. Okay, and then sine of inverse of 1. Okay, all right. Now, The problem is when you look at all your triangles, and we've done them all, if you do sine of any of the triangles, it doesn't have that. So the question is where would you get sine of being of 1? Well, the only spot that could be is really pi over 2, okay? And the reason being is that would be on there, 0 and 1, okay? X and y, sine is opposite over hypotenuse, so that's y over h, or 1, and we always know our h is 1, so 1 over 1. So that's why that answer there is just pi over 2. Okay, moving on to this one, cosine is 0. All right, so if I look at where I'm restricted from here to here. Okay, well this becomes simple logic here. Okay, all right, where would cosine be there? Well, cosine is a over h or x over h. Well, we always know our h is 1. Well, the only way I'm going to get 0 is to be here. Okay, so that's got to be this one, which would be at pi over 2, because the x would be 0. So it's got to be pi over 2, because at pi over 2, the x is 0, and the y is 1, so 0 over 1. So that's the only way that would work. Square root of 3 over 2, so that's a over h. So when I drew my triangle, that's got to be square root of 3. That's got to be 2. That's got to be 1. If you look at that, that's got to be the pi over 6 triangle. Okay, it's cosine. All right, so cosine is restricted to here or here. Well, since cosine is positive, it's got to be in this. So that's why that's got to be pi over 6. Okay, all right, going on to these. So what you have to do in these is you have to work in compartments here. Okay, all right. By the way, you may cancel these. You do not have to do those. We're not attempting those. All right. So what we have to figure out is what is our angle off of sine there. Okay. All right. So this asks for basically an angle. All right. So what I would do is do the inverse of tangent. This would be 1. Whoops. Shift this. All right, you have 4 over 3, which is 53.1 degrees. And then you would just do the sine of that. Okay? That would be a calculator question. We would not be expecting you to be able to figure that out. That would be 0.799. Okay? All right, the same thing here. I would want to do inverse sine first. So inverse sine of 2/3. That's 41.81. And then I would do the cotangent of that. Okay? All right, so what I would want to figure out is what's the tangent of 41.81. And then do 1 divided by that. So actually I would want to do 1 divided by the tangent of 41.81. So that's 1.11. Okay? Now, these involve, these ones you should be able to do without a calculator, these next 3, okay? Because the cotangent of 5 pi over 6, okay, that traces back to the pi over 6 one, which is 1 square root of 3 and 2. Okay, cotangent of that would be square root of 3, okay, over 1. Okay, all right, it would be square root of 3 over 1. Since I would be in the 5 pi over 6, which would be here, I would be in the negative result there. Okay, so that would have to be negative. Now I apply the inverse of tangent. Okay, well I know that tangent would have to be here or here, because that's where it is restricted. Okay, since the tangent is negative, I know it can't be here, so I gotta be in this part right there to get that. All right, so how do I get tangent of that? Well, let's look at that. That's going to be O over A, which is square root of 3 over 1 and 2, which that is going to be the square root, that's going to be the pi over 3 triangle. That would be the one that would create that. So since it's got to be down there, my answer's got to be negative pi over 3. Okay, this is 3 pi over 4, which that would put me in this quadrant right here, because it's slightly less than 1. Okay, that would trace back to square root of 2, square root of 2, and 2. All right, since I'm doing cotangent, that's square root of 2 over square root of 2, which would be 1. Since I'm in this quadrant, the only thing that would be is sine and cosecant, so what that result would have to be is negative 1. So I'm doing inverse cosine of negative 1. I am restricted, all right, to this quadrant and this quadrant. Now, I have to look at these 3 things. What things would give me negative 1? Well, I've got A over H. Well, I know that the H is 1. Well, how can I get negative 1? Well, if you look at your points, the only one that has X or h being -1 would be right here. So that would have to be pi for my answer, okay? Sine of 3 pi over 4, it is the same quadrant as what we just did. It is the same triangle that we just did, square root of 2, square root of 2, and 2. Now sine would be square root of 2 over 2. Since it's in this quadrant, we know it's going to be positive. Okay, so I'm going to do sine inverse of square root of 2 over 2. Now if I apply that to where I'm restricted to these two things. Well, since sine is positive, that would be here, making it pi over 4, because that's the triangle that would create. Okay? All right, so what I'd have to do on this one is I would have to create a triangle of 4, okay, on that one. We're going to go ahead and skip this problem. You're not going to have to do something like that.